method is the same, huh? You can try it with to the power 1 by gamma also. So it says find the elasticity of substitution between consumption in period 1 and consumption in period 2. Now, elasticity of substitution has a formula which is given by D of ln C2 by C1 upon D of ln MRS. So basically what elasticity of substitution tells us, that if I have any indifference curve and I go ahead and I find the slope of this indifference curve, that's MRS. If I pass a ray through the origin, that gives me the ratio between y-axis and x-axis. So here I'm taking consumption in period 2, consumption in period 1. I'm passing a ray through the origin here also. So basically it tells me as I go from point A to point B, how does not only the ratio change in which I consume the two commodities, but as compared to it, how does my rate of substitution change? How does my slope changes? Both the things are changing if you look at it. So if you notice, not only my slope became flatter, but my ray through the origin also changed. Its slope also changed. So how does this change? This is what this tells me. So it's very simple. If my utility function is C1 to the power gamma plus C2 to the power gamma upon gamma, I'll find MRS. So MRS will be mu C1 by mu C2. So how utility changes when C1 changes, how utility changes when C2 changes. So if I differentiate with respect to C1, I will get gamma C1 to the power gamma minus 1 upon gamma. And if I differentiate with respect to C2, I will get gamma C2 to the power gamma minus 1 upon gamma. So this will be C1 upon C2 to the power gamma minus 1. This is my MRS. Now, just one thing here. See, in the numerator, I have C2 by C1. MRS is coming as a ratio of C1 by C2. But we know if I have X by Y, and if I want to switch this, I can write that this is Y by X to the power minus 1. So I can multiply the power with the negative 1 and I can switch what comes inside. So this is exactly what I'm going to do. Let me go ahead and let me say that this is equal to C2 by C1 and switch the power with minus 1. So into minus 1 gamma minus 1. So this will be C2 by C1 into 1 minus gamma. This will be MRS. Now let's take log on both sides. So ln MRS is equal to ln C2 by C1 to the power 1 minus gamma. So ln MRS is equal to 1 minus gamma ln C2 by C1. Now what do I have to find out? I have to differentiate on both sides and then find d of ln C2 by C1 upon d of MRS. So if I take differentiation on both sides, this has d on both sides. And then d of ln C2 by C1 upon d of ln MRS. This will be given by 1 upon 1 minus gamma. So the answer to this question will be both. D. So pretty straightforward question. You just have to know this formula. Achha, a lot of people do this mistake. They start by literally finding ln MRS. So yahan pe na, they would have found out, first they will find MRS, then they will do ln MRS. Then they will go ahead and differentiate that. then they will find ln C2, differentiate that, and then divide the two. No. In most of the cases, and we know when, if it is a homothetic function, MRS will actually be a ratio of C1 and C2. So you will be able to get your numerator only by solving MRS. See, like this. I got MRS as a function of C2 by C1. So, you know, when I took log, I already had both the things with me. And I just manipulated it a bit and I got the answer. So I don't literally have to find C2 by C1 and MRS and divide. No. I just have to find MRS, see that it will be a function of C2 by C1, and solve for elasticity of substitution. So the answer is D. Now,